everyone, and welcome to live show 136, Unearthing Power, Geothermal Energy Explained. I'm your host, coming to you live from the Other Side studio in Minsk, Belarus, on this May 28th, 2025, at 8 p.m. Minsk time. That's 6 p.m. London, 1 p.m. New York, and 4 a.m. Sydney. We're streaming on Rumble, YouTube, and X, so wherever you are, thanks for tuning in. Tonight, we're diving into the fascinating world of geothermal energy with our incredible guest, Jan. We'll uncover what geothermal energy is, how it works, and why it's a game changer for a sustainable future. Get ready for an eye-opening conversation. As always, please share this stream, hit the thumbs up, and subscribe to our channels to keep up with the shows. Let's get started. Hi, Dan. How are you?
Hey, Dave. Not bad, thanks. Yourself? I'm good.
Well, it's good. Let's get on with it.
Let's crack on.
What is geothermal energy, and how does it differ from other renewable energy sources?
Let me tell you something most men
Sorry, I don't know what's going on my phone. My phone just decided to just turn itself on and play YouTube. That's a bad start. Actually, I'll turn it off, I think.
Shall we do that again?
Yeah, that just started playing on its own. I got a notification. Yeah.
What is geothermal energy, and how does it differ from other renewable energy sources?
Well, geothermal basically means heat from the earth. So it differs from other renewable energy because it's base load. It's basically like a conventional power stations where there's power 24/7. Doesn't rely on the wind or the sun to shine, or the tides to flow, or pumping water for hydro dams, that kind of thing. So it's 24 hours a day power, constant power, and it can deliver a lot of the heat need and power needs for the whole world, really. And majority of places on the planet can actually, use geothermal energy, depending on how deep they drill.
How is geothermal energy harnessed from the Earth's heat?
So first, you also need to get the drilling rig onto the location. You can do it in cities. You can do it in rural areas, obviously, mountainous areas. You need to drill a well, depending on the geothermal gradient of the region. For instance, in the UK, the average geothermal gradient is about 25 degrees Celsius per kilometre. But in places like Cornwall, where there's lots of granite, it's about 35 to 37 degrees per kilometre. So if you drill down 5 kilometre well, you're looking at about 200 degrees Celsius. Other parts of the world, when you're on active tectonic plates, it's a lot hotter than that. You can drill 100 to 200 metres and be 400 degrees Celsius.
What are the primary types of geothermal power plants?
There's 3 types off the top of my head. The binary power stations are ones where you have a gas turbine and you pump the water around it, and you go through like a working fluid, which is probably like liquid propane. That flashes at low boiling point, and then that obviously passes past the blades of the turbine. Then you cool the water, you cool that propane down again, condense it, and then you have like a heat exchange between the fluid in the well and the fluid going through the turbine. Then you also have flash plants, which you probably get from tectonic plate areas. There's the third one. I do apologise, but at the top of my head, I've actually forgotten the name of it. But there is about 3 or 4 different types of power stations, basically, and they're very similar to like gas turbines, where you're heating water to then blast through a turbine and they go through a generator on one side. But in this case, the water's already heated from the earth, so you haven't got to pay to heat it.
Okay, cool. What geological conditions are ideal for geothermal energy production?
Would you mind bringing up slide 4, please? Yeah, so obviously here is a representation of the planet itself. Everything highlighted in red is active plate margins. You've got the one around America then, the South American plate. You've got the one through the Mediterranean, the East African rift. And then you've got the Pacific plates as well, through Japan and around Papua. And also you've got the mid-ocean ridge, the Azores, Ascension Island, and Iceland. So wherever there's close proximity to magma and lava, you can drill quite shallow depths and get a lot of heat. I mean, Iceland, for instance, I think the majority of their hot water system just heating is powered by geothermal, and a big chunk of their power as well. It comes with a caveat. You're on an active plate margin, so there is going to be volcanic eruptions and earthquakes, that kind of stuff, really, which can damage the infrastructure. There are some wells in South America which actually seal themselves because after an earthquake, the steel casing in the well just collapses and gets crushed. So if you're a proximity to any plate margin, Indonesia, for instance, Philippines, they've got a lot of geothermal wells. And then on the other side of it as well, when you have something called EGS, which is an enhanced geothermal systems, places like granites, so wherever you have granite, you can drill into it, because the granite's basically like a big radiator. Because of the breakdown of the isotopes, thorium, uranium, potassium, they give off energy when the half-life breaks down, and that heat energy is stored in the granite. It's so dense. So you've got these big radiators wherever you have granite plutons, places like southern Germany, France, Cornwall in the UK, Scotland, and anywhere else where there's granite as well, really. So that's the other side of the geothermal world, really. The EGS plants and the active plate margins.
How widespread is geothermal energy used globally?
The biggest players in the world currently, if you can bring up slide 2, please, I can show you. So if you see here, United States is probably the global leader, and that's mostly in places like Utah, California, Nevada. There is other places in the States where they can do it, but it's mostly focused in the kind of the south, or southwest, the west of the States. Indonesia is huge, obviously. The Philippines on the same plate margin. Turkey, again, they're really huge. They're drilling wells constantly in Turkey, and they're building so many power plants. Most of it is close to the Mediterranean side, where you have all the Aegean plate activity around there. New Zealand, obviously. I think I've bathed in some hot springs in close proximity to some of the geothermal plants, and that was, 9 years ago before I really got into geothermal. But if I knew at the time, I would have gone for a visit, because you can go and visit some of these plants. Mexico, obviously. Kenya is really big with geothermal. East African Rift Valley. There's one of the companies called KenGen. It's one of the biggest in the world, really. Italy, again, is a global leader like Iceland, and then there's some in Japan. And the other would be the rest of the other European countries that are trying to drill around the EU, and also some of their island nations in the Caribbean, which have quite a lot of wells getting planned to be drilled in the future, and the EU are paying for a lot of those.
What are the main advantages of geothermal energy over hydrocarbon fuels?
Base load. There's 2 different types of wells. There's artesian, which is self-flowing, or there's ones where you've got to pump the water out, so you need a high temperature pump for that. Also, you need power to power that. So I think it's obviously a lot cheaper. You haven't got to drill an oil well and then produce it, refine it, transport it, and use it to burn in power stations. So it costs the same to drill a well wherever you are. I always say you don't get a geothermal discount because it's green. So unfortunately, you rent a drilling rig and the services that come with that, which is very expensive, and it doesn't come with a discount. Some of the employers in the geothermal world think that they can probably pay their staff a little bit less. But unfortunately, when it comes to services, the big players like Schlumberger, Baker Hughes, the drilling contractors like Marriott and Icelandic Drilling Company, they don't say, "Oh, it's a geothermal well, we'll help you out, we'll give you a discount." They say, "No, we're drilling a hole, and it's very expensive." So the cost of drilling itself is very similar to land drilling any oil and gas well. Drilling is drilling, basically. Doesn't matter what you're trying to do, you still got to take precautions to have the right equipment and tools there, and the right fail safes, and you need the people experience as well. I mean, a rig in the UK, land rig, is going to be about £25,000 a day to drill down to 3,000 meters. If you're going to go deeper, it's going to be about £50,000 a day, going to 5,000 meters. So the spread costs of these wells is £100,000 to £200,000 a day, really, depending on the operations that are happening. So it's big money. These wells, to get a well multilateral, so more than one exit from the well, you're probably going to be about £40 million, I'd say. Oof. And then obviously you've got to build a power station, which is £15 million, and to pay yourself back to get your return, it's going to be probably about 10 years until you balance the books.
How does geothermal energy contribute to reducing carbon emissions?
Once you drill it and you basically build the plant, there isn't really any emissions from it. There's a misconception. If you go to, please, slide number 8, there's a misconception that there's lots of emissions with geothermal, like from the steam, but you only really produce steam when you're well testing. So when you're flowing the well, so here we got a picture from Kenya. They're going through some steam. They've got a wellhead in the center there with the valves open. It's going to steam separators. Basically, the hot fluid is coming out the well. It's artesian because it's on the East African Rift Valley. It's hitting these big steam separators, that the fluid is flashing to steam and releasing the energy into the atmosphere, like a boiling kettle, basically. So that's in the well testing phase, when you're working out how much fluid you can get through the well and what temperature it is. Once they've done their test for a few days, they'll shut those wells down and they'll plumb them into the power station and they'll just let it flow. So there is basically zero emissions once it's up and running. But the emissions come from the diesel you need for the drilling rig, unless it's connected to the grid. Some places don't have grid connection. They're better if they do because it's cheaper. And then obviously the manufacturing and transportation and building of the plant, which can take a couple of years really. So once it's built, it's basically self-sufficient, and it doesn't have any emissions at all.
What are the limitations or challenges of a geothermal energy development?
Getting the financing is the biggest problem. The wells that have been drilled in the UK, the original well in Cornwall, which is where I live, it's called Roseman-Hours. It was built, and it was actually drilled in the 80s and tested in the 90s. That had a lot of government funding and some private funding, but that was mothballed. It's a shame because it was a good well actually. In those days, you could hydraulically frack it. So they actually created their own reservoir down there by injecting high pressure fluids down into the well and creating a bigger fracture network. Nowadays, it's very more difficult because of the memorandum on fracking in the UK. It's difficult to do that. Sorry, can you just please remind me again what the question was?
What are the limitations or challenges of a geothermal energy development?
For funding, I was involved in a well in Cornwall, United Towns, and that took 10 years to get funding, and then it took about a year basically to drill the 2 wells, and then it took a couple of more years to develop it and get and start building the power station. So it's the appetite in the UK for geothermal is not really there yet. There is signs that it could be something that can benefit the UK energy and job skills in the future, but it's just generally the funding. I mean, the government has the finances to drill wells all over the UK. Every hospital and new council estate should really have their own district heating and geothermal heat, which you only need to drill a few kilometres, can provide that basically. So yeah, it's the appetite and the financing. A lot of the finance is coming from private investment groups and hedge funds and that kind of thing, basically, where it should be a lot of money should come from the government if they want to really push it along. Because the more wells you drill, the cheaper it gets in the long term.
You mentioned hospitals. You think that if the hospital would pay to get a geothermal energy system running in their area, and then they could sell that excess energy and all that to the houses around?
100%. Yeah, and you don't really need a big footprint. I mean, depending how deep you need to get, I mean, there's plenty of space around hospitals, especially car parks, and also you could do it in an area away from a hospital and have a insulated pipeline to supply the hot water from the power station itself. There were plans to do that in Cornwall to heat the Laszczak hospital, which is the main hospital, and to heat also a new King Charles town is building called Langarth. But that would have been about a 7-kilometre pipeline, insulated pipeline. It was very expensive to actually put into place. Would have been a lot cheaper to actually drill their own wells on their own land and for the cost of the pipeline itself. So yeah, it's definitely possible because nowadays a lot of hospitals have their own power stations, or they get grid power and they've got gas generation backup in case the power goes down. So even industry, there's a lot of industry needs hot water for processing. So all industries and you wouldn't believe it, most skyscrapers in London and that actually have their own geothermal wells, but they're basically large ground source heat pumps because these big glass and steel structures generate so much heat from the sun that their air conditioning basically they pump the hot air into the ground, and then it comes up and they get self-cooling basically. So it's more common than you think, but it needs to be rolled out on a bigger scale, a more industrial scale basically.
How does the cost of geothermal energy compare to solar or wind energy?
It's definitely expensive because all the services. I mean, obviously, the supply chain for solar panels and for wind turbines is so established now. It wasn't cheap in the past, but it is now. It's so common. But it's not only the cost of actually drilling. It's the cost of building the power station, which are expensive. But the difference is the footprint. You can have maybe a 2 or 3 acre site for a geothermal power plant, and that will generate 3 to 6 megawatts of power. Or you can have a 10 or 20 acre field of solar panels. And then, with a geothermal power plant, you're not disturbing any of the wildlife. You're not reflecting that sunshine back into the atmosphere. You're not blinding at birds. You're not hitting raptors with the blades of the turbines and killing birds of prey. And also you have the noise. And not to be quite honest, the rollout of wind turbines across the whole UK, even in beautiful highlands and all these rural areas, it's a blight on the horizon. When you see a wind farm, you think, how ugly does that look? Basically, I know a lot of them now are offshore, but still, I think it's when I look out my window now, I can see dozens of wind turbines.
Yeah, and also it'll be constant energy instead of up and down with the wind or the sun as well.
And also recycling. I mean, once you, there's no real way of recycling solar panels and wind turbines. I know they're trying to convert some of their houses, some of their actual winding houses on the turbines into small pod houses. That's a kind of a niche thing. But when you decommission a geothermal power plant, you basically just unbolt everything and you fill the well full of cement, and that's it. And you walk away, and then you can use that ground for housing or farmland again. There's just decommissioning the well, plugging and abandoning it. It's when, for instance, for solar panels, you're losing that biodiversity, and you're losing the arable land. We spoke earlier about why don't they put them on social housing? Well, they don't want to do that because that means that the people in social housing get free power. They want to do it on big, large-scale solar farms of 20, 30, 40, 100 acre green field areas, because they want to sell the power back to the consumer at the going rate, which is only going to go up.
Yeah, you can't give free stuff to people. That's bad. What role does drilling technology play in geothermal energy extraction?
So years ago, all the technological focus was on oil and gas and basically drilling the wells faster, more efficient, saving time, hitting your targets, not getting stuck in the hole, not losing the well, basically, to bad practices. And now there is really a focus from industry where they're developing high temperature tools, more durable drill bits which can drill longer without getting worn and damaged. Because traditional drill bits, tricones, or the tungsten bits, basically could last maybe 4 or 5 days in the hole. They could drill 250 to 400 meters. But now there are companies in the States that have really pushed the boundaries, and they've the average rate of penetration when you're drilling these wells, especially in granite, it's about 4 to 8 meters an hour. So work at the cost of that, it's very expensive per hour to drill. So in the States, they've designed some new PDC bits, which is diamond crystalline, drill bits, which powder diamonds, and they can drill up to 15 meters per hour. They do get dull over time, but because you're drilling so fast, you have a quick change around when you pull tools out of hole and make them up again and go back in and go drilling again. They actually pay for themselves. So you never save money buying cheap drill bits. You always have to invest in good quality drill bits, and they pay for themselves basically with how fast they drill and how durable they are. So there is technology out there which has been developed. There is a big need for it. But again, you develop a really high temperature tool that can, last 2 weeks in hole. There's going to be demand for it, and you can charge a big premium for it because it'll be in demand.
What is enhanced geothermal systems, EGS, and how does it expand geothermal potential?
Yeah, so the EGS system is basically drilling in granite normally. So you enhance it by, you kind of correct your own reservoir. So for instance, in Cornwall, we've got, massive granite plutons underneath the whole kind of peninsula of Cornwall. And you've got a thin overlay of sedimentary rock, Devonian metamorphic rock called Killas. But then transcending all these formations are something called the cross-course faults, which are large fault structures, which are mostly quartz veins, which are a couple of 100 meters wide, actually, fractured quartz. So the idea is you intercept those fracture networks at depth, and then you're able to circulate fluids through them, and obviously get your hot water from depth, and then inject the water once it's cooled down higher up. And it's called a closed loop system, basically. So that fluid never sees the light of day. It stays inside all of the pipe work and the heat exchange at the surface. So it's for areas where you haven't got active plate margins. You can drill into these big radiators, which are the granites, because of obviously the breakdown in the isotopes, the thorium, uranium, potassium, and that heat energy is stored there. It's been there for millions of years, and you'll never cool it down. So the wells we drilled in Cornwall, there's been a couple so far. There's been 3 in total in the last 40 years. Roseman House and Penryn, United Downs and St Day, and then you've got the Eden project, which has their own geothermal well, but that's only for heat at the moment. So they're basically heating the biomes with their own geothermal well, which is fantastic. But the plan is for United Downs, they're nearly finished commissioning the power station, so they'll have power, heat, and lithium. So the big thing now is there's a big drive for these wells because of lithium in granites. Some granites have natural lithium in them, You can either mine it from granites at surface, which have the lithium micas in them, or because lithium is hydrophilic, it loves to detach stuff to water. So if you can find these brines at depth, they're very rich in lithium.
How deep must wells be drilled to access viable geothermal resources?
Depends on geothermal gradient. In Iceland, a few hundred meters. Same in New Zealand. In places like the continent are far away from plate margins, you've got to go down kilometers. So for heating only, anywhere in the UK, you can probably drill 2 to 3 kilometers and you'll have 80 degrees Celsius at least. But if you really want the high temperature fluids, which you need for power generation over 120 degrees, you've got to drill down. You've got to drill down to over 4K. So the target's normally between 4 and 5K for power generation in the UK, especially in granites, places like the Grampians in Scotland, other places in the UK as well. So this is very kindly borrowed from open source material from the BGS, the British Geological Society. So there's a heat flow map of the UK and Northern Ireland. As you can see, anything in red is the high thermal density of anywhere in the UK. So you've got where the granites are, basically up in the Grampians. There's some granites also up near Bishop Auckland and obviously Lake District. And then down in Cornwall, you can see it's red hot because you've got Dartmoor, Bodmidmoor, Penwith, and all the different granite plutons which are down here. So the average 26 degrees per kilometre, but Cornwall is around 35 to 37 degrees, basically. So anywhere around there you can drill. You can drill anywhere in the UK. However, you've got to drill deeper. So where we are now in Cornwall, it's mostly granites, like I said, but all the other sedimentary basins in the UK, they're more sedimentary aquifers. You can get heat from them, but you've got to draw a lot deeper to get the same temperatures, basically. So if you just want to have heat generation, you can drill 2 or 3 kilometres. But if you need power, you'll go deeper.
Can the geothermal energy be used in regions without natural hot springs or geysers?
Yes, it can. Like I said, you can drill in sedimentary basins. There's places like in Bavaria, where in Germany, they're drilling into a sandstone reservoir at depth. And because you've got the meteoric water flowing through the mountains, it heats up when it comes in contact to the granites at depth. And that flows naturally. The places where you probably couldn't do it would be the northern and southern hemispheres, where the permafrost is, like Alaska, Canada, northern Russia. If you've got 300 or 400 meters of permafrost, it'd be very difficult to get hot water surface unless you have an insulated casing system there, which is possible, but I don't think it's feasible.
How reliable is geothermal energy compared to other renewables like solar and wind?
Very reliable. If you've got an artesian well, there's no pump in there you just need a pump to basically pump back into the ground. If you've got if you have an ESP, electronic submersible pump, they're very reliable nowadays. They use about a megawatt of power, so you need a lot of power to generate them. But the power station is symbiotic, so once you get it going, it will get power from the power station. They're very reliable. They can last a year without service. And they also have line shaft pumps as well, which are very reliable. So it depends on the kit you have. But usually the EGS power plants in Germany and France, they shut down once a year for maintenance.
What is the lifespan of a typical geothermal power plant?
I think the oldest one in the world is still going. I think it's in Italy. I think it's about 100 years old. But generally it's about 25 to 30 years, I would suggest, depending on corrosion and silting up, because obviously you get minerals percolating from the fluids once they change temperature and pressure. So that's managed. They do dose these systems with acid to kind of dissolve some of this scale. But as long as you maintain it, there's really no end to these projects.
How does geothermal energy impact local ecosystems during development?
The drilling properly. You've also got the noise, which is highly regulated in the UK. As long as you have the planning and you work from your planning, but drilling a well doesn't really impact the environment too much. It's a small footprint. You're using a smaller bit of land. You do have some vehicle movement, bringing equipment, and then deliveries of products and services and people, that kind of thing. But it's got a tiny footprint and a tiny impact on the biodiversity. And once actually it's been built, I think it's tiny. It's a 2-acre site. It's nothing compared to solar and wind and that kind of thing, really.
Yeah, I think you mentioned this before. Are there risks in seismic activity associated with geothermal projects?
There is, yeah, especially in active plate margins. It's kind of part and parcel. You do get earthquakes which damage infrastructure. Once you drill into an EGS system at granites, you will. I mean, there's nowhere in the world which doesn't have thousands of micro quakes every single day. It is highly monitored and regulated by the BGS. When we were drilling the sites in Cornwall, we had 10 active seismometers in a network around the site and out, 10 kilometers away as well to map. Then you can geolocate the source of the actual seismic event. But generally speaking, when you're drilling it, you do sometimes have some minor seismic events which can be felt. Funny enough, some people are very sensitive to them. Even a one magnitude can pick up, which is a few millimeters of movement. Basically, it's equivalent of like a bus driving past your house. Some people are very, very sensitive, especially if your house was built on bedrock, which is quite common in Cornwall, so you can feel it. But there's never been an event in Cornwall that's damaged any property or causing any alarm to people generally. I mean, we did have some people contacting the office when we were drilling because they believed they felt something, and we checked our data and there was nothing generated from us. The only other side is when you're doing some well testing, when you're doing injectivity testing, you can sometimes have a cluster of events, which are very, very difficult to even notice, but they are there. And it's all, you've got to have 100% transparency as well, because obviously the government, the BGS has their own network of seismometers, and they actually use our data as well. Previously they would use the data, which is all open source basically. So there are events, and events did happen, but they were tiny in comparison to the more common natural events. And the biggest one that happened naturally in Cornwall a couple of years ago was about a magnitude 3. But generally, with testing, it's below magnitude 1, and they're very infrequent. But people don't realise there's micro events happening all the time, hundreds a day, if not thousands a day, which are never picked up.
What advancements in geothermal technology are currently being researched?
I think the biggest is how to generate power from lower temperatures, and also drill bits and high temperature tools are probably the biggest development, and also ESP pumps, high temperature pumps that they're going to last a year or so in the ground without maintenance. Once you run a pump, it's quite expensive to pull it again. If you need to, you need to have the equipment there and the people to actually pull it out of the hole and maintain it. And they're normally sat down at about a kilometre in depth anyway. So you've got to triple that pipe out on all the power cables and then obviously rebuild them and maintain them and put them back in the hole again.
How can geothermal energy be used for residential heating and cooling?
It can be, and it is. It does happen. If you had a well that was in proximity to a modern housing development, which had a district heating system installed, it'd be very difficult to do it to traditional older houses because, the property that I'm in is a cottage and it's very poorly insulated, and it wouldn't really work. But these modern houses, which are very highly insulated, you don't need a lot of heat to warm them. So yeah, it does. It can work quite easily. As long as obviously it's planned ahead of time, you can quite easily drill a shallow well for heating only. And I think there is some projects in the UK that are planned for that as well.
What is a geothermal heat pump and how does it work?
If you're talking about ground source heat pumps, they're basically a small pump that pumps fluid in a closed loop system, like a U-shaped system underground into a shallow borehole. And it's just basically like a heat transfer. You have something like glycol or something in the fluid, and it's a heat transfer, it's a heat pump. So that the actual fluid is cooled down in the hole in the ground of the well, and then obviously when it gets to the surface, you generate heat from actually cooling the pump down.
How does geothermal energy support energy independence for countries?
It's going to be a suite of all energy. I think we need to invest in all different types of technologies and energies, but it's base load, and you haven't got to rely on importing any fossil fuels from abroad and from nefarious countries. So, like for instance, Iceland and New Zealand, they generate a lot of power and heat from their own resource, and it's theirs. And it's never going to cool down. It's always going to be there.
What are the biggest barriers to scaling up geothermal energy globally?
Investment, supply chain of tools and equipment, the appetite of the countries to drill their wells, and that's basically it. Really, if people got the money and the appetite for it, they can do anything.
How does government policy influence geothermal energy adoption?
It's being developed more and more over the years from some of the companies that have drilled the wells in the UK, and lobbying the government for help basically in financing and obviously help with planning, because it's very difficult to get projects over the line when it comes to local planning. There's always objections from the community that don't really understand the projects, and they believe that they're going to be noisy and smelly and steam and all those kind of things, when in fact that's not the case. So it's a challenge. It is a great challenge, but it's all, I think it starts with education basically. So there is a massive amount of community outreach when it comes to geothermal projects, to just educate the population so they know exactly the benefits of these projects. Yeah, and you need to have a social license to, with the local community, so they can allow you to actually do the project. Because if you get on the wrong side of the community, it's going to be very, very difficult to get these projects over the line. Sorry, my dog's he wants to go for a wee.
Yeah. What role do subsidies or incentives play in geothermal project development?
There is none in the UK at the moment, but there are a lot of subsidies globally. For instance, KenGen in Kenya, they generate a lot of geothermal power, and they get a lot of carbon credits from the UN. So it seems like the UN divvies out the carbon credits, which are collected from everybody in the world, for just flying a plane or filling the car full of diesel. And then they get lots of subsidies, which are significant, actually, in the hundreds of millions of dollars per year. So they're incentivized, and they're actually they're a very profitable company. So it's quite strange how these credits are used in a business model which is already working very well. It would be nice to see that some of these funds invested in some of the smaller companies in the UK that are trying to develop this technology. But at the moment, there is no funding. If there is very little. All the funding comes from private enterprises and, like I said, investment banks and hedge funds, which obviously you got to pay back. And the bottom line's tight in the first place when you're talking about hundreds of millions of pounds to drill a couple of wells and to build power stations. So there needs to be more funding from the government for sure.
How does geothermal energy integrate into existing power grids?
Same as any power company, as long as you've got the grid network nearby, which is always a factor. You don't want to be putting in, megawatts of power cables to the nearest transformer if it's 20 miles away. So the sites need to be close to the infrastructure for the import and export licenses of power, but also you need to be close to the good roads to deliver the equipment, because you need to bring the trucks in to bring the rigs there, and the actual piece of kit need to build the power station, which all comes on trucks.
What are some successful case studies of geothermal energy projects worldwide?
There's hundreds. New Zealand, Turkey. There's one in the Azores which works well. United Downs in Cornwall, which I worked on. That's days away from commissioning the power plant. That's been a long work in progress. So there is a good case. So that would be the first case study. That would be the first actual power to the grid. When it's turned on later on this year. So there's numerous case studies. It's just a quick Google, you can find them. They're very easy to find.
How does geothermal energy perform in extreme climates or remote locations?
A lot. Obviously, extreme climates depends on what you mean by that, but you can do it anywhere as long as you can get the roads in there to actually build the rigs. So, Philippines, Central America, the islands of Guadeloupe, in Caribbean, the French island of Guadeloupe, that had a well drilled a couple of years ago by Icelandic drilling company, and the EU paid for that. So they're building the power station now. I know Marriott Drilling are currently on Ascension Island, because the British government overseas territories, they want to have the geothermal well there, because it's obviously on the active plate margin, the mid-ocean ridge. They want to actually have their own power and heat generation down there as well, rather than importing diesel for the generators. And it makes sense because it's an isolated island community. But also they want to have an all-weather runway. So the RAF would like to de-ice the runways, which is also a thing which is happening in Norway as well, and other extreme climates where they want to have a heated runway. There's no better way than circulating your own geothermal water around in a network of pipes and hoses to defrost the runways. So anywhere apart from probably permafrost, I'd say it's feasible.
So Alaska's out, Siberia?
Antarctica, yeah, those kind of places.
Yeah, okay. What materials are used in geothermal power plant construction to withstand high temperatures?
A lot of it is just basically metal and metal fittings and flanges. A lot of stainless steel, basically. So they're expensive to make and manufacture. Take a long time to build, but they're tried and tested. There's several companies in the world which make good geothermal power stations. Italians, Americans make some really good ones. So they're established throughout there, but it's all non-corrosive material.
Mm-hmm. How is water usage managed in geothermal power generation?
Depends on the type of power station, really. Some power stations, they discharge the fluid at surface, like the Blue Lagoon, for instance, in Iceland. If you can open up slide 9, please, you get a representation of that. So here we have the famous Blue Lagoon. People don't realise is they're actually swimming in the discharge fluid in the geothermal power plant. So that's basically meteoric fluid, rainwater in the subsurface, which interacts with the magma, the lava below, and the rocks below, and it's superheated, 300 or 400 degrees. It goes through the power station, it gets cooled down, and then they basically dump it into these lagoons, and people go and pay to swim in it because it's like a spa. I haven't been myself, but I'd like to one day. So, for instance, they obviously don't re-inject the fluid back into the ground; they just discharge it into the lagoons. But an EGS system is a closed loop, so that the fluid you produce from subsurface to brine doesn't see daylight. It goes back into the ground again. You have a injection well and a production well. You produce the fluid out, you use it on a heat exchange, you pump it down to the ground again.
Can geothermal energy be paired with renewables in hybrid systems?
Yeah, definitely. So you can actually power the downhole pump with wind and hydro and solar, and also get a good tariff for that to pay for it, because the pumps are like about a megawatt of power they draw down. And if your power station is only generating 3 megawatts, it makes sense to import wind and export geothermal, because you'll get a better strike price for geothermal. And it's base load, so it's 24 hours a day. You haven't got to rely on the wind, the sun, the tides, that kind of thing, basically. So yeah, it does work. That's the whole idea of it, basically. Or you can actually just generate the power from battery storage. Your excess power that you can't put into the grid. If you've got grid restraints, you can have a nearby storage of batteries, which can then be your backup power.
What are the maintenance requirements for a geothermal power plant?
Depending on the region, the world, but like I said earlier, probably about once a year you shut down for maintenance for a week or two. They're so established now, and they've refined the equipment so well that you really don't want to have any downtime. So they're built for that, basically.
How do these geothermal energy power plants and systems contribute to job creation in the energy sector?
The biggest job creation is the drilling phase, I would say, when you've got maybe 100 people working on the project for 6, 7, 8, 9 months. And then obviously after that, it's the construction of the power plant. And really, it's a bit of a fallacy to say that it does generate a lot of jobs, because once the power station is up and running, you're going to have 2 or 3 people working, and that's it. You're going to have you're going to basically have a control room with a SCADA system where guys or girls will sit there and look at the touch screens and monitor all the systems, and that's it. Unless you've got maintenance to do, unless you've got to pull the pump out of the well. One of the biggest things at the moment, the buzzword for the last couple of years, is transferable skills from oil and gas drilling in the UK to geothermal. I'm still waiting for those opportunities, because the skills are there, the people are there. With the current government wanting to minimise or even stop any more exploration in the North Sea, you've got 20,000 people working offshore, and they contribute to hundreds of thousands of other jobs that are linked to oil and gas, the actual logistics chain. So where are they going to find the work? Because there's no heavy industry in the UK anymore. It's all getting imported. We're trying to import everything to the UK. Well, I mean, if we do upscale geothermal, and there's dozens of rigs drilling heat and power wells in the UK, then fantastic. There's people out there that can do the work and want the work. And for me, for sure. But yeah, those transferable skills are there, but there isn't the opportunity or the investment currently.
What is the potential for geothermal energy in developing countries?
They're already doing it, and they're getting the money from the West to do it as well. So there's a lot of investment. Kenya, for instance, is a global leader in geothermal. Ethiopia as well. Anywhere where you're close to heat, you can drill a well, and it's happening across the Caribbean. A lot of the Caribbean nations are actually having their own wells drilled now. So yeah, it's there's equal opportunity in a developing world, if not more, because they're probably closer to active plate margins. So yeah, there's no distinction between what countries people are from and drilling a well, and they have the money and they have the investment, and there's loads of geothermal wells drilled around the world now. It's really taking off.
How do you assess the economic viability of a geothermal project?
It's quite simple. If you want heat and you're importing gas and you're having gas boilers, but then you drill a well and you don't buy gas anymore. If you want to have reliable base load, you drill down to 5K and you put in a power station. It's never going to produce as much power as a 20-acre solar farm, but it's base load and it's got a tiny footprint. And the more you drill, the cheaper it's going to get. It's got when you scale it up, it's going to get cheaper, which is that's the way things happen.
You think with the UK's net zero obsession that they'd be doing this all over the place, wouldn't you?
If you want to get to net zero, that's one of the things you have to do, and they're not doing it. So do they really want to get to net zero? Because there's so many barriers in place in drilling these wells. My mind is boggled how the fact it's so difficult to explain and lobby the government. Not only this government, the previous government was lobbied for many years and showed very little interest. And we had many visits to the site. I met lots of high-ranking ministers, and it was just difficult to get the message across. No one really cares. And
or maybe those in power haven't got any money in those areas yet.
There's no skin in the game. Exactly, they've got no skin in the game because it's so new, and you have to educate them on these projects. But it's an absolute no-brainer. If you want to heat industry, housing, heat runways, heat airports, they've all got the space. Look at Heathrow Airport. You could put a rig anywhere. I know you've got the planes landing in that, but there's anywhere you can drill these wells. In the middle of a city. I mean, in Paris, they're drilling geothermal wells in the middle of Paris, in a car park surrounded by flats, and they do it. There's Germany, which is one of the most regulated planning environments in the world. They're doing it all over the place. We're way behind the European Union and Turkey when it comes to these wells. And we've got the same geology, if not better geology than they have. I mean, look at Holland, for instance. In Rotterdam, all of the big greenhouses that grow all the flowers. The farmers pay for their own geothermal wells to heat the biomes and heat their greenhouses. The government doesn't pay; the farmers pay. Then we buy the flowers. Well, we've got the same geology across the water in Suffolk and Essex and Kent.
What are the key differences between high temperature and low temperature geothermal resources?
Obviously, high temperature, you can drill, it's more shallow to drill, you haven't got to drill so deep. And low temperature is mostly used for just heat only, whereas high temperature, you can have power generation as well. You need about 120 degrees, the current technology, 120 degrees Celsius is what you need to generate power, to flash the working fluid in the actual power plant itself to generate the power over the turbine.
How is geothermal energy monitored to ensure sustainable extraction?
It's kind of self-monitored, really. Obviously, you have a control room on each power plant, and they'll be monitoring pressures and flow rates and temperatures and any deviation from that. Once the well is established, there should be a baseline you should follow. If temperature starts dropping off, then there's a problem with the well, basically. So yeah, they're monitored internally. There is growing not overreach. There is growing regulation from the UK government. They're trying to get the same people involved in oil and gas regulation to regulate the geothermal because it's very new. They're working with the geothermal companies in the UK to actually regulate and to bring up regulation procedures. So currently, if you drill a well in the UK, you know, something called BSOR, which is like the borehole drilling regulations of the UK. But we also have to abide by the UK Oil and Gas Authority, which has changed now to the UK Energy Transition. I'm sorry, I've forgotten, but they've changed their name now to a different branch. But basically, Health and Safety Executive that covers everything, and also we're monitored by the Oil and Gas Authority, which is the transitional authority. I think it's changed the name to. So yeah, we have to, like for instance, have well control qualifications from all the senior personnel. So the drilling supervisors, drilling manager, the drillers, the assistant drillers, the tool pushers on the rig, and they also have to have a blowout preventer, and all the associated equipment to shut the well in generally, it's not like Deepwater Horizon where you have a big kick and it's oil and gas going to surface. If you lose the fluid in a well, you get steam at surface, and all you need to do is pump down cold water to kill it. And that's simple as that, really. So you'll have a diverter set up, so if it does flash in the well, you just vent it off for a steam separator, and then you would pump cold water down there and kill the well.
What misconceptions about geothermal energy are common among the public?
They think there's going to be a big plume of smoke and steam coming from it, and a smell and a noise, when it's really not the case. There's concerns about seismicity as well, which obviously need to be educated to the public that this is not really a common thing. And when it comes to drilling as well, what happens, there is lots of seismic events all the time, like I said earlier, but there people are generally worried, and just because of lack of exposure to the technology and the education that we can provide.
How can local communities be engaged to support local thermal projects?
Having lots of open days, having lots of question and answer sessions with the public, obviously going to parish council meetings, planning application meetings, contacting the companies directly. There is a huge amount of community outreach when it comes to these projects, because, like I said earlier, you need to have a social license to operate, which is basically getting the local community on board. And there's been some cases with neighbours who haven't been happy with the fact that there's a drilling rig down the road from them. So I've heard stories where they've been given cruises, they've been given holidays, and they've been compensated if they have a genuine grievance with the companies, which, and in old industries, I mean, even mining industries, if you're developing a new mine in the UK, you have to, be amenable to the local community and not impact their lives in any way. But it is really important. I mean, nobody really wants a rig next door to their house for 9 months. So yeah, it's difficult. You have to really get them on board. And a lot of people do support it, naturally. They know it's going to be a good thing. One of the incentives which you can do is you can say, right, okay, you're our neighbours. When the power station's complete, we'll give you a preferential tariff. We'll give you, discounted on your power. And you could be even tied into the district heating network if that ever happens in the future.
What is the future outlook for geothermal energy in the next decade?
It's going to get more and more common. I think there will be a transition from drilling oil and gas over to geothermal. It's already a big thing, geothermal internationally anyway, but I hope that the UK puts its big boy pants on and starts drilling these wells everywhere, because it really is a no-brainer when it comes to heat, especially heat. But if you got the resource for power as well, and the lithium, which is always a sweetener, then I can't see why you wouldn't do it. It's kind of self-destructive if you can't harness this basically free energy.
So how can viewers learn more or get involved in supporting geothermal energy initiatives?
Just contact your local government if you can, your local councillors, the local MPs. There are a couple of MPs out there which are really pushing for geothermal in their regions, and just lobby the government on behalf of your community, and also these future projects need to have some sort of engagement with the community where they're partners or they're shareholders, so that they actually benefit their lives. Because you can get a solar farm next door to your house, and that goes into the grid and goes up the line. There needs to be a relationship with the community where, if they're going to have it in their own backyard, they need to benefit from it. So if you're going to have a geothermal power station, you're going to have excess power, you're going to have excess heat, then distribute that to the community so that they can be involved in that and they can be a stakeholder and a shareholder.
Okay.
And they believe, this is our power station. We're really proud of this. We don't mind about 9 months of some noise and trucks coming. We'll support it because we know we're going to be invested in it. It's going to invest in us. We're going to get something back for it, especially with the cost of living and energy prices are going to go one way, and that's up. We're not going to say, oh wow, we're going to cut all power. The costs are going to come down. They won't ever come down. Everything's always going to go up. That's a sick reality of life.
Yeah. Lastly, have I forgotten anything, or do you want to comment on anything else that?
No, I think we've covered it. The big emphasis is that we need to give the government a big boot up the backside and say, look, if you want to meet these targets that you're creating, then geothermal is going to be one of the industries which can help you support that. and it will generate jobs. If you've got 15, 20 rigs in the UK, you can have thousands of people working, and there's also the other associated jobs on that as well. It's just a whole supply chain. So we need to drop it down a gear and start drilling for everyone's benefit, for jobs, for communities, and for these projects which can generate endless amounts of heat and energy.
Okay. So that's a wrap for live show 136, Unearthing the Power, Geothermal Energy Explained. Huge thanks to our amazing guest, Jan. Thank you very much for shedding light on the incredible potential of geothermal energy. We hope you've learned as much as I have tonight. If you've enjoyed the show, please share it with your friends, give the thumbs up and subscribe to our channels on Rumble, YouTube and X to catch all future episodes. We're live from the Other Side studio in Minsk, Belarus, and we'll be back for more fascinating discussions soon. Until then, stay curious, and we'll see you next time. Goodbye. Bye, Jan.
See you later.